So here I'm looking at alkene addition reactions. If you want to check out this sheet right now and try them out, if you go to the link in the description, it'll take you to my site. And under the organic section, there's a bunch of these. And you can use the title in the YouTube video here to figure out which one it is. I'm going to go through and just kind of, I haven't looked at these, I'm just going to kind of go through and look at what I see and how I come up with the answer for them. So the first one, I've got a double bond here, alkene. I'm adding to it an HCl. So that means that I'm going to add a hydrogen to one of the carbons, a chlorine to the other. And the big question there is, which one gets which one? Okay? So Markovnikov's rule is what we're kind of getting at here. And the H plus is going to add first. This is a source of electrons. And so I'm looking for an electrophilic substance. I want something with positive charge. And between the H plus and the chloride, I want this to interact first. This is going to be repelled by this initially, so they're not going to interact at first. So the first thing that's going to happen is I'm going to form a bond between this and the H plus. Now, hydrogen can't form that kind of triangular intermediate like a halogen can, because it doesn't have the bonding capacity to do so. So the hydrogen is either going to go to this carbon, or it's going to go to that carbon. And what happens is, the hydrogen will always go to the carbon with fewer things attached to it. So it's going to go to this carbon here, because this carbon has this attached, and this carbon has this and this attached. So whatever one doesn't get the hydrogen is going to have a positive charge to it. I want the positive charge, the carbocation intermediate, to be on that one, because this is able to pull electron density from here, and from here. Whereas this one can only pull from here and here. So it's going to happen where the H plus is going to go onto this carbon. And then after that, the chloride with its negative charge is going to form a bond with that carbocation intermediate. So when I draw my final answer here, I'm going to have CH3, CH2, C. Now this one has the methyl group here. It will add the chloride, and then I'll have a CH2, CH3, where this carbon is this one, and this carbon is this one. Okay? Now alternatively, you could have put the chloride here and the hydrogen there, but that's not going to happen for the majority of this reaction just because of the carbocation stability. Okay? Second reaction, I start with an alkene. This is ethene. So I can tell by the H4 that it's not saturated, it's got a double bond, and I end up with an alcohol. That means I'm going to be doing an addition reaction with water. Okay, and that's where I'm going to pull the OH from. But in order for this to start, I'm going to need an acid catalyst. Now I want to be careful. I don't want to add an acid catalyst like HCl, because that might react with the ethene itself. So I want to add a catalyst that's an acid, that's a strong acid, but something that's got an anion that might not react with this. So I'm going to choose sulfuric acid. And that's how I would come up with that. Then the bottom one is acetylene. So I have a triple bond. And same type of pi bonding, easy to break, and a strong source of electrons. So I'm going to add, it ends up with C2H2Br4. All I'm going to do is add bromine. Now some of you might be worried about the numbers on this, but when I write bromine here, I don't mean a single molecule. I mean a good chunk of orange-brown bromine. And so that's going to continue to add to this even after you become the alkene with the dibromoalkene. You're going to add another bromine to that double bond until you end up with saturated compound, which will have 2 bromines on each carbon. Like that, but with all of its electron pairs. Okay? So if we scroll down, look at some more. Okay. So number 4, I have an alkene. This is styrene, and I'm adding an acid to it. And that acid's not something that's going to add to it. So what's going to happen here is this is going to be a polymerization reaction. I'm going to take this styrene monomer and make it into a polymer. So this double bond is going to be disrupted by the acid, and then another monomer is going to do an electrophilic addition to that carbocation, and they're going to link. And so I'm going to end up with a big long chain. And the way you represent that is you put brackets with a bond coming in. Here's your first carbon. Here's your second carbon. There's the end. And then this carbon has 2 hydrogens on it. And then this carbon has a hydrogen and then a benzene ring. So I'm going to go a little smaller than the normal scale. And I'm going to form that repeating n times. Okay, or I'll have a couple of them that will have some fraction of that. This next one, I have an alkene to start and I end up with an alkane. So that's hydrogenation. I'm making this saturated. I'm going to add hydrogen to it. And for hydrogen, it's important that you put a metal catalyst with that, because hydrogen is not reactive enough to add to this without it. There are a bunch of ones you could do. We could do platinum, we could do nickel, we could do palladium. There's definitely a few. The last one here, I have CH3CH3. This is an alkane. I'm ending up with a chlorine atom added to an alkane. Now, alkanes are extremely unreactive. So for this has got to be a photocatalyzed reaction, where I'm putting UV light into it, and that's going to go ahead and break some bonds, actually form some free radicals. So I need UV light, ultraviolet light, and that's going to initiate this. And then I also need a source of the chlorine. So mixing a halogen, an alkane, and UV light, I'm going to end up with products like this. Now this one would have other products as well. This is just one of the ones. Okay, so there are 6 kind of reactions that you would see in mostly in addition to an alkene sense.